Which of the following has the largest oxidation number for chlorine? A. MgCl2, B. CCl4, C. Cl2, or D. ClO2 with a -1 charge. By now you should be able to figure out that the chlorine in MgCl2 are monatomic ions, called chloride, which have a charge of -1. The rule is that the oxidation number of a monatomic species is simply equal to its charge. Therefore, the oxidation number of Cl in magnesium chloride is -1. If you don't remember how to figure out that chlorine in MgCl2 are monatomic ions, here's a quick review. Mg is a metallic element. Any compound containing a metallic element is ionic. Therefore, MgCl2 is an ionic compound. Referring to a periodic table, we find that Mg belongs to group 2a. Ions from these elements are always found to have a charge of +2 in naturally occurring substances. In other words, there is only one naturally occurring ion of magnesium, a monatomic ion with a charge of +2. Since a compound is neutral, the Cl2 in magnesium chloride represents either two monatomic chloride ions, each with a -1 charge, or one diatomic ion consisting of two chlorines with a -2 charge. Only the monatomic chloride ion is known to exist in nature. In uses B, C, and D, chlorine is sharing electrons with other atoms and is part of a polyatomic species. For atoms in a polyatomic species, the oxidation number is defined as a fictitious charge determined by assigning ownership of shared electrons to the more electronegative atom. For the nonmetals that we commonly encounter, here is the order of electronegativity. Fluorine is the most electronegative, followed by oxygen. In general, within a given row in the periodic table, electronegativity increases towards the halogens. So in row 2, fluorine is the most electronegative. In row 3, chlorine is the most electronegative. Let's now examine choice B, carbon tetrachloride. We can see that chlorine is more electronegative than carbon. Therefore, chlorine is assigned a negative oxidation number, and carbon is assigned a positive oxidation number. To figure out the actual oxidation number of Cl and C, we can draw the Lewis structure and compare the number of valence electrons that each atom appears to own with the number of valence electrons that an isolated neutral atom has. In a lot of cases, the cases you'll encounter on test if you have not yet covered molecular structure in class, we can use a simpler rule. Typically when dealing with a polyatomic species, the most electronegative atom is assigned an oxidation number of -1 if it's a halogen. It's assigned an oxidation number of -2 if it belongs to group 6a, -3 if it belongs to group 5a, and -4 if it belongs to group 4a. Therefore, in carbon tetrachloride, chlorine, which is a halogen, is assigned an oxidation number of -1. It is treated as though it were a chloride ion with a -1 charge. Let's examine choice D, the chloride ion. In choice D, the chlorine is sharing electrons with more electronegative atoms, oxygen. Therefore, the O atoms are assigned ownership of the shared electrons. Since oxygen belongs to group 6a, the oxidation number of each oxygen is -2. In other words, each oxygen atom is treated as if it were an oxide ion, which has a -2 charge. We figure out the oxidation number of chlorine using the rule that the sum of oxidation numbers of all the atoms in a polyatomic species equals the charge of the species. So if X is the oxidation number of chlorine, if we add this to the oxidation numbers of the two oxygen atoms, the sum should equal to the charge of the polyatomic species, which in this case is -1. Solving for X, we get X equals +3. The oxidation number of chlorine in chloride ion is +3. Finally, let's examine choice C. Here, Each chlorine is sharing electrons with another chlorine atom. Since neither atom is more electronegative than the other, ownership of shared electrons is evenly split between the two chlorine atoms. It is logical to assume that both atoms have the same electronegativity. Since the molecule has a zero charge, the sum of the oxidation numbers of both atoms is equal to 0. Therefore, each atom has an oxidation number of 0. This is generally true for atoms in any pure elemental substance. The oxidation number of each and every atom in a pure elemental substance is 0. To summarize, we found the oxidation numbers of chlorine to be -1 in choice A, -1 in choice B, 0 in choice C, and +3 in choice D. The species in which chlorine has the highest oxidation number is chlorite. Think of it this way. Oxidation is defined as a loss of electrons. The more an atom shares electrons with more electronegative atoms, the more it would appear to have lost electrons, and the higher its oxidation number. In choice D, Cl is sharing electrons with more electronegative oxygen atoms. Indeed, since oxygen is the second most electronegative element, the more an atom bonds with oxygen, the more it loses electrons, the higher its oxidation number will become, and the more oxidized it is compared to an isolated neutral atom. One exception, of course, is fluorine, which is the only atom more electronegative than oxygen.